In this video, we're going to be discussing the CPV-GE-PT-8 IO-Link CPV valve terminal. And this is an IO-Link enabled device, and in this case we're going to be putting a CTEU-DN, which is a DeviceNet, on top of the node, and we're going to communicate to a 1756 DNV module, or a scanner, in a Rockwell CLogix PLC, and we're going to use an older L61 controller and an older ENBT Ethernet IP. Even though this is not the ENBT, it's disguised as the ENBT. And the first thing we can look at are the settings on the CTEU-DN, and that is the DIL switches. And on the DIL switches on the face of the unit, we have the power connector, and we have the DeviceNet wiring, and then we have this DIL switch pack. There's two DIL switches, and in this case I have exactly what I have reserved here in green. So I have the first 1, 2, 3, 4 DIL switches turned on, and this represents 15 binary. And on the second DIL switch, the first two switches are used for nothing. 3 and 4 are used for the baud. So I have set it for 500 kilobaud, and the status is off and the reset is off. So that's important to understand that we have the baud, because out of the factory it's 125 kilobaud. And one of the first parts of commissioning is to understand the firmware versions of all the devices. So I'm going to open up our Linux Classic, and under communications we configure the driver. We go into the CPX AP. We added basically a Ethernet IP driver, and then when we add this, we come into here and we're picking the network adapter that we're going to be looking at. In this case, I've already got this set up, and when I scan the network, here's the 100. If I tunnel down, I can see the L61 processor, then the ENBT, and the DNB. And if we right click on the L61, we can see that it's version 19, so it's old school, because most DeviceNet is old school. That's why I'm using the older devices. The ENBT, actually we got to pick this one at the top here. Device properties. It's version 6.006. That's really important, because if you have older firmware, it's probably not going to work. And then we have the 1756 DNB 1102. 1102. So we have an understanding about what all of our devices are flashed to with the firmware. And when we commission, we're going to work away from the bottom up. So the first thing we want to look for is the EDS file for the CTEU-DN, and we're going to navigate to the internet for this. So you can start up your browser, and I'm just going to drag my browser over. So I'm already at the Festo website, so www.festo.com, and I just want to show you that the CPV10-GE-PT-8 is in fact what this looks like, and the CTEU-DE or DN, which is the DeviceNet, it screws into the top hat. And when we want to search for the DeviceNet files, we go to Show Details, click on Downloads, click on Software, and we'll see here that we have the DeviceNet file. And I'm going to download this. And now we go to where I unzip the file. So I have these files which I've unzipped and put them into a directory. It really is irrelevant which directory because you need to understand where that is. And the next thing we're going to do is start up the DeviceNet software, RS Networks for DeviceNet. So I've taken the liberty of starting a new version, and in my case, again, I'm using older software. This is version 24, and that's pretty old. 28 is the latest. And the first thing we're going to do is we're going to install the EDS file. So we go up to Tools, EDS Wizard. There are other ways to do this, but this is one of the simplest because you're going to use this tool anyway. We click on Next. We click on Register EDS File. I'm just going to pick a single file. You could usually do a whole directory, but I'm going to pick a single file. Pick the file in the directory that you've located and unzipped it to. Make sure you've unzipped it. Click on Open. Click the Next button. Hopefully it's green like this. Keep going. Keep going. Keep going. And finish. And then you give it a minute for the DeviceNet library to be updated. And when it's finished updating, you can go search for it. One way or another, you go under the vendor, Festo, and you'll see that we have this, and so on and so forth. So now we have registered the EDS file. The next step is going to be to configure the 1756 DNB scanner. So if I go back to the picture, this 1756 DNB scanner is what we're going to configure using the RS Networks for DeviceNet, and we're going to configure this node within the scanner. Go back to RS Networks, and the simplest place to do this is online. So I'm going to click this online button, navigate. This is where we tunnel. So we're going through the 100, getting to the DNB. So if we go back to the picture, we're going through the Ethernet card, across the backplane, and into the DeviceNet card. And we click on DeviceNet, we click on OK, and it's going to do a scan of the network. So we see here that we have the node 15, which is the CTEU-DN, and we have the DNB, which is more normally address 0. And this was scanned, so we're online right now. If you want to stay online, you can say continuous, but don't need to do that because it'll upload or download depending on the situation. So if I double click on the device, we can see a few things here. So we see the address is 15. You can upload all the parameters. You can group them all. And if you double click, there's the serial number, consumer length, double click. You see that it's connected to the CPV10-GE-PT-8, which is the IO link, so it's basically communicating DeviceNet. So it's communicating from this CTEU-DN to this device CPV via IO link, and then this DeviceNet is communicating to the Rockwell via DeviceNet. And we can keep going and seeing all the different parameters, so I'm going to go on. So this is the first step that seems a little deceiving. So it can be up to 4 bytes. Just keep that in mind. In our case, the CPV valve terminal is only 2 bytes. The next step is going to be to configure the DeviceNet scanner and add this device into the scanner. First, I'd like to show you the visual. So I've got the node set up here. I have the red LED flashing, which is the ModNet light, and then the IO light is green and the OK light is OK. And on the device, on the CTEU-DN, I have the MNS light flashing, and the IO light is off. So the IO light has to be solid green, which means that you're communicating to the device. So move this out of the way, and we're going to double click on the device. And we will zoom in, and we're going to go to the scan list. So it sees this CTEU-DN on the network, and now we move this over to this scan list. And we're going to turn AutoMap off, apply, yes, yes. And now that this is applied, now we need to edit the IO parameters, and we need to change the byte size to 2. If actually, what I'll do is I'll leave this as a 4, and we'll see what happens. Okay, so it took the default that we showed you earlier, which was underneath this properties of the CTEU-DN. It took it as a 4. Hit OK, and I want to map the CTEU-DN not on 0, so I'm going to unmap this. If I'd been over here and done this, one way or another, the auto map, when I added it already. So I unmapped it, and now I'm going to pick the starting address. So I'm going to pick 15 because I want the information to be on this starting address, because that's how I designed the system. I'm going to say auto map, and now it's placed the CTEU-DN on this device. So now I'm going to hit apply. It's going to download. Yes. And now we're going to go see what is going on the network. And right now we have node 15, error 77. Error 77. So I'm going to minimize this, and I'm going to go to the DeviceNet user manual from Rockwell. So there's your publication number. And in that library we have a list of the errors, and we will see here that the error number 77 is basically saying that the data size expected by the device does not match the scan list entry. So this is because we picked the wrong size data. So now we're going to go back to the scanner. We're going to edit again. I'll just zoom in here again. And we're going to go to the scan list, and we're going to edit. So you pick on the device, you edit IO, and we're going to change this to 2 bytes because there's only 2 bytes. Say yes, yes, apply, yes, yes. Go to the outputs. We scroll down to the 15. I suppose it unmapped it completely. So now we're going to click on 15, say auto map, and apply. Yes, and yes. And now we can say OK. And if we go back to the DeviceNet scanner, we see here that we have green light. We're in run mode, and we have no problems. So we have effectively configured the DeviceNet scanner card using the RS networks for DeviceNet software. And now we would do a save as. I've already saved it as this particular file here, so you can go back online with an offline file. It's just going to synchronize. So it is the same thing, and I'm using my saved DeviceNet file, my .dnt extension. Okay, the next step is going to be in the PLC. So I have opened a project, click on new, and I have selected the L61 processor as the PLC. So during startup, I would have been prompted with this exact information. I picked the L61 version 19 to match the firmware on the PLC, version 19 software, so on and so forth. And in this case, I'm in a 7-slot chassis. If we look at the chassis right here, we have 1, 2, 3, 4, 5, 6, 7 slots. I'm only using them all. And the first thing that we need to do is we need to add my Ethernet IP master. So quickly say new module after right click, go down to communications. The newer software is obviously better. You can do a search for things. And in this case, we're going to give it a name. We're going to give it a address. And it's in slot 1. We need to match this to what is in the controller, in which case it is 6.6. We showed this at the beginning of the video. And that's all we need to do for this device. Click on OK. Give it a second to add it. Hopefully it doesn't crash. Good. Now we're going to add another module. You can type in 1756-DNV. Next, close. I'm going to say OK. And we are using version 11. It was 11.1. Hit OK. Give it a name. And we're on compatible keying, and I'm going to click on the default input size, output size, and status size. So I'm going to click OK. We'll change the requested packet interval to 10 seconds or 10 milliseconds, and this is really all you need to do at this point. Hit OK. So now we've added the PLC, the MBT card, the DNB card scanner. The next step is going to be just simply to set the communication path. So under Who Active, typically you would come in and it would be like this. You would click on the device, and you would scan this, get to here, you're picking the PLC, and then you would say set project path and close. And at this point we can hit save, and when we do a download we can simply go here and do a download because we've set the path now. So I'm just going to download this. Ignore my little program routines over on the left and imagine that I'm just downloading the modules. See if the hardware's working. So we're online and we can see the PLC, properties of the EMBT, module info. There's the 6.6 as we set up. This right here, if you've never set the IP, you might have to do one last thing where you do the set. And that's it for this one. Okay. We look at the DNB. This is what it looks like while we're online. And This is the information. It's actually 11.2. And you can see that node 15 is in the scan list. And it's important to understand what that is looking at. Well, if we come and we unmap this device, which we've already mapped, so I'm going to unmap it, I'm going to apply, so I'm destroying what the card had, and I'm going to go back to this status, and we'll see that it's not active anymore. And we'll also notice here that the scanner is in idle mode. And I'm going to go back and put this back in. Auto maps off to, okay, yes. Go to 15. Auto map, okay, yes. As soon as we do this, then we're back in the scan list, but we're still in idle mode. And I'll leave this open. In order to get the scanner into run mode, we need to go to the output table, go to the command register, and put a 1 under register run. Put a 1, and we'll see that we're in run mode now. So at this point, the data should be flowing, going back and forth between the scanner and the PLC across the backplane. And if I go to the screen, we'll see that both these LEDs, this is the MNS and the IO LED, are both solid. If I go back and put this out of run mode, put it back into 0, go back to the picture, we'll see that the IO is flashing because the IO is not being scanned. It's configured, but it's not being scanned. So I'm just going to put this into run mode. We're back into run. You can see it changed state. I'll leave it in run mode. So theoretically, in the main routine, should really just have that on all the time. Okay, command register run. Unless you're going to do something with it while you're offline. At this point, because the IO is flowing, we go to the controller tags, find the output data, go to this. I'm just going to manipulate the windows a little bit. So that I have the picture in the background. And if we put 65,535, we'll see that all the LEDs are now turned on for the valves. And that's the simple way of commissioning the node. At this point, it's up to you to either map these data to tag structures or use the raw data. So in this case, you can add a description. And then we can label the individual. And it continues. So valve coil, so put a 0. If I put a 1 here, valve coil 14 is coming on. That one's not being used. The next one, and the next one, and it will continue up until 15, where 15. So this is the concept behind commissioning the node. So now we have everything working to the device. I hope this helps you with your project and accelerates your project as well. And I will include some links to a download of some sample software in the project.